So hello friends, welcome to online lecture series. This is the 12th lecture of unit number 1, that is wave mechanics. So in our previous video we calculated some numericals which are based on particle in one dimensional and particle in three dimensional box. Okay, so today we start a new theory, that is characteristic of wave function. Characteristic of wave function. So there are two characteristics. First one is internal nodal points. Internal nodal points. And second one is nature of wave function. So there are two different characteristics in your syllabus. First one is internal nodal points and second one is nature of wave function. Okay, so first one is internal nodal points. Internal nodal points. So what do you mean by nodal points? Nodal points indicate a date point when the probability of find particle is 0. So at nodal point the probability of find particle is 0. It means at that point the value of psi is equal to 0. Okay, so for n quantum number, the value of nodal points is equal to n minus 1. Okay, so for n quantum number the value of nodal points is equal to n minus 1. It means for ground state level, so what do you mean by ground state? The value of n is equal to 1. Okay, so at that time the value of nodal points is equal to n minus 1. It means the value of n is equal to 1 for ground state. So the nodal points will become 1 minus 1 is equal to 0. It means at ground state the value of nodal points are 0. It means for ground state there are no nodal points present. So for next level it means the value of n is equal to 2. So for n is equal to 2, it means second excited or second energy level, the value of n is equal to 2. It means the nodal points is equal to 2 minus 1, because here the value of n is equal to 2. It means 2 minus 1 is equal to 1 nodal point present at n is equal to 2, second energy level. Okay, so for n is equal to 3, the value of nodal points will become is equal to 3 minus 1. It means 2 nodal points are present in n is equal to 3 energy level. Okay, so first one is now wave function of normalized wave function of particle in one dimensional box, that is psi is equal to under root 2a sine n pi upon x into a. Okay, so this is the normalized wave function for particle in one dimensional box. So for n is equal to 2, first for ground state level, the value of n is equal to 1. So for n is equal to 1, suppose the wave function is psi 1. At that time, the value of psi 1 will become under root 2a sine. Here the value of n is equal to 1. So sine 1 into pi, it means pi upon x into a. Okay. So at that time, the value of nodal points is equal to 0. It means for n is equal to 1, the nodal points is equal to 0. Okay. And for n is equal to 2, suppose the wave function is sine 2. Sine 2 is equal to under root 2a sine 2 pi upon x into a, because we put the value of n is equal to 2 in normalized wave function, 2 into pi upon x into a. Okay. So at that time n is equal to 2, nodal points will become 1. It means for n is equal to 2, the value of nodal point is equal to 1. Okay. And for n is equal to 3, the wave function sine 3 is equal to under root 2a sine 3 pi upon x into a. At that time, the nodal points will become 2 different nodal points present at third energy level. Okay. So for n is equal to 1 non-nodal points, it means for n is equal to 1, there is no point present at that time, the value of psi is equal to, it means the probability of find particle is 0. Okay. So I explained this theoretical process in graphical representation. Okay. So this is the simple one-dimensional box. Okay. So here the value of x is equal to 0. Here the value of x is equal to a. Okay. This is the first energy level. It means the value of n is equal to 1. This is the second energy level, and this one is the third energy level. Here the value of n is equal to 2, and for that n is equal to 3. Okay. So for n is equal to 1, the wave function will become psi 1. N is equal to 2, at that time sine 2, n is equal to 3 and sine 3. Okay. So for graphical representation of psi 1 is like this type. The graphical representation of psi 1 is like this type. Okay. And the graphical representation of sine 2 is okay, and graphical representation of sine 3 is okay. So here in this case, this point indicates the value of that point, the probability of find particle, it means psi is equal to 0. Here x is equal to 0, here x is equal to 1. This is the first energy level, this is the second energy level, and this one is the third energy level. Okay. So here the value of n is equal to 1, here value of n is equal to 2, and this is the third energy level. At n is equal to 1, wave function will become psi 1. This is for psi 1, this is for psi 2, and this is for sine 3. Okay. So first energy level, the graph is like this type. Okay. So for second energy level, graph will become this type, and for third energy level, graph will become this type. Okay. So here in this case, first one is At boundary condition, this is the boundary condition, or at boundary condition this point indicates at this point there are no particles. It is also called nodal point, but we not consider in these nodal points because boundaries nodal points are not consider in this theory. Okay, so here the value of psi is equal to 0 because our particle is present inside the box. At boundary points a particle is not present. It means these are nodal points, but we will not consider these nodal points. Okay, because it is the internal nodal points. Internal means inside the box. Here we can see that here this point indicates the value of psi is equal to 0. It means there are no particle at this point. Okay, so for psi 2 it means n is equal to 2, one nodal point is present, and for n is equal to 2 there are two different nodal points are present. Okay, so here for psi n is equal to 1 there are no nodal points. Here n is equal to 2 there are one nodal points, and n is equal to 3 there are two different nodal points are obtained. Okay, we will not consider this boundary nodal points in calculation because it is a internal nodal points. It means nodal points inside the box, not at boundary. Okay, so now position of nodal points. Okay, so first here in this case n is equal to 1 there are no nodal points. It means there are no position of nodal point in this case. Now n is equal to 2. It means suppose at that time n is equal to, this is first part, second part, third part, and this one is fourth part. Okay, so first part 1 2 3 4 there are four parts. It means the value of here is a is equal to, here the value becomes x is equal to a by 2 because one straight line is divided into two four parts. This one the value of here is a by 4. Here 2a by 4 it means a by 2. Here 3a by 4, and here a, x is equal to a. Okay, so this part is a by 4, this one is 2a by 4, it means a by 2, and this is the 3a by 4, and this is a. Okay, so in this case for n is equal to 3, here the value of this part total straight line divided in which parts? 1 2 3 4 5 6. Okay, so here a by 6, at this point 2a by 6, at this point 3a by 6, at this point 4a by 6, at this point 5a by 6, and last one is 6a by 6. It means x is equal to a. Okay, so here in this case now position of nodal points. So for n is equal to 1 there are no nodal points, so position is not in this case. And for n is equal to 2 there are one nodal points at position a by 2. Position is a by 2. For n is equal to 2 one nodal point is present at the position a by 2. And here now position of nodal points. For n is equal to 1 it means no nodal points. For n is equal to 2 the nodal point is present at the position a by 2. Position is a by 2. And for n is equal to 3 we can see that there are two different nodal points are present. First one is 2a by 6 and second one is 4a by 6. First one is 2a by 6 and second one is 4a by 6. Okay, So in some books it is represented like 2 3s are 6, a by 3, and 2 into 2 is equal to 4, and 2 into 3 is equal to 6. 2 cancel, 2a by 3. In some books these nodal points are also represented at a by 3 and 2a by 3. Both are equal, 2a by 6 or a by 3 and 4a by 6 or 2a by 3. Both values are equal. Okay, so here for n is equal to 3, two nodal points are obtained. First one is the position is 2a by 6 and second one position is 4a by 6. Okay, so in this graph the value of maximum, it means it is called a maxima and it is called minima. It is also maxima, it is maxima, and this one will become minima. Okay, so in this case maxima and minima represent the inverse of a nodal points. What do you mean by nodal points? At nodal points the value of psi is equal to 0. It means there are no particle present at this point. But at maxima and minima, the most probability of find particle is maxima as well as in minima. Most probability of find particle, it is inverse of nodal points. There are not in nodal points there are no particle at that point, there are no particle present, but at minima and maxima the highest probability of find particle. Okay, so in this case suppose psi 1 maxima is in psi 1 there are no nodal points. It means for n is equal to 1 there are no nodal points, and maxima is a by 2. For psi 1 maxima is a by 2 because this value becomes a by 2. Okay, suppose I divide this graph into two parts, then this will be this value will becomes a by 2 and this is also a by 2. Okay, so a by 2 into a by 2 is equal to 0 to a. Okay, but for n by 2 the value of maxima a by 4 and 3a by 4, n is equal to 1. For n is equal to 1 there is only one maxima is present at condition a by 2. For n is equal to 2 the value of highest find probability of particle is a by 4 and 3a by 4. A by 4 and 3a by 4 indicates at that point the probability of find particle is highest. Okay, and n is equal to 3 the highest probability of find particle is a by 6, 3a by 6 and 5a by 6. A by 6, 3a by 6 and 5a by 6. Okay, so this is the first characteristic of wave function, that is internal nodal points. Okay, so what do you mean by nodal point? At that point the value of find particle is 0. It is called nodal points. Okay, so the equation of nodal points is equal to n minus 1. It means n is equal to 1, at that time nodal point will become 0. N is equal to 2, nodal point 1, n is equal to 3, 2 nodal points are obtained. Okay, so this is the graphical representation of nodal points. At nodal points the value of found particle psi is equal to 0. Okay, and in this case we will consider only internal nodal points. At boundary condition, at boundary nodal points there are also find particle, probability of find particle is 0, but we will not consider in this case because at boundary, at any point of the boundary the value of find particle is 0. Okay, so and now minima and maxima indicates the highest probability of find particle. Okay, so this is the general graphical expression of nodal points. Okay, so the second a characteristic of nature of wave function.